Okay, so this video is going to go through combinations of transformations. Essentially, what happens is you always start with a parent function. It might be root x, that's called parent function. And then if you apply some transformation, say shifting it up just by 2 or something, that's called the image. Parent function can also be thought of as the pre-image, so the thing before you've done any translation, dilation, etc. Okay, so find the equation of the image when the graph of y equals root x is translated 6 units in the negative direction of the x-axis, reflected in the y-axis, and dilated by a factor of 2 from the x-axis. So essentially, we're trying to find the equation of the image, and we call that y dash. Now, it works because what we do is we keep track of how the coordinates have changed throughout the process, and they're related in some way, okay? So y dash in this case is y plus 2. So y dash is written in terms of the old coordinate system of y, or the pre-image stuff, so y plus 2. So the process is we find y in terms of y dash, we find x in terms of x dash, and then we substitute these expressions into the original equation and rearrange for y dash. So again, this works because the image coordinates are related to the old coordinates by this mapping. Okay, every single y value has gone up by 2 in the small example here. All right, so the first thing we need to do is just identify how the old coordinates have been transformed to the new coordinates. We call the image of x the image of y. Then we equate the image of x to something in terms of x, and the image of y and something in terms of y. Then we substitute into the original equation and solve for y dash, which is the equation of the image. Okay, so first we have to get our head around what's happening. So every single xy coordinate is first translated 6 units in the negative direction of the x-axis. So here's some point on the graph, and every single xy coordinate has been translated 6 units in the negative direction of the x-axis. So negative direction of the x-axis going this way. So maybe it goes to here now. So it's x minus 6, and the y value stayed the same. Okay, that was the first thing that happened. Then it's reflected in the y-axis. So the y-axis is acting like a mirror. Okay, so the y-axis is a mirror. That point gets reflected. Okay, so where would the image be if the y-axis is a mirror? Might make it a little bit easier if I make this here. Okay, so this point here is x minus 6y. If we reflect in the y-axis, then that point is reflected about there. So we reflect across the y-axis, and what's happened to the coordinates now? It is the negative of the x minus 6. So negative x minus 6, and the y value has stayed the same. Okay, can we see how the yellow thing is the mirror? This point here reflected would be this point here, so the same distance across. Next one is dilated by a factor of 2 from the x-axis. So this means that it's going away from the x-axis by a factor of 2, so you're doing a multiplication. So what's happening is that the x value stays the same, which is now minus x minus 6, and the y value has been multiplied by 2. Okay. So we've found our process xy. First you translate, then you reflect the whole thing, and then you stretch, you dilate. Okay, so could write that in one step, and it goes to expand the brackets minus x plus 6 and 2y. Okay, we've done the first step. Second step is to equate. Okay, so x dash in terms of the old coordinates is minus x plus 6. Y dash in terms of the old coordinates is 2y. Then we have to rearrange. So get the old coordinates in terms of the new coordinates. Y dash equals 2y, so y equals y dash 1, 2. And now what I have is an expression for x in terms of the new coordinates and an expression for y in terms of the new coordinate system. So in my original equation, I have a y and an x. Now I can just substitute in and rearrange for y dash. So we go y equals root x. Well, I know y is this thing, so I substitute in, and I know x is this thing, so I substitute in. And now I rearrange to solve for y dash, which is the equation of the image. Alternatively, that could be written as the following. Okay, so just to review, first you have to identify how the new coordinates are related to the old coordinates by doing this picture. Then you need to equate your image of x with something in terms of x, your image of y and something in terms of y. And substitute into the original equation. Maybe we should add here, really, first you need to solve for x in terms of x dash and y in terms of y dash first before you substitute in. Substitute in, rearrange, and you can say the equation of the image is, you can drop the dashes now because they're just sort of to tell the difference between the new coordinate system and old coordinate system. So you can just drop the dashes after that. All right, and that's it.